So for today class, we'll be discussing about rheology, okay, or simply the study of flow, okay, flow of fluids. Now class, why do you think it's important for us to study rheology or how fluids flow? Okay, so I just want to get your class, your inputs lang muna before we start with the lesson. Okay, how important is it for us to be able to study the flow properties of liquids? Okay, sa tingin nyo lang, bakit kaya importante siya? It doesn't have to be class, just your your opinion lang. Okay? Kasi it's always a part of our lesson, okay, in pharmacy, okay? Now we discuss about rheology, right? Or how fluids flow. Okay, ano may mga properties ng mga fluids natin. So bakit sa tingin niyo importante class na pag-aralan natin ng rheology? Okay, anyone? Yun, Mr. Reyes, siguro it can relate to stability. True, very good. Okay? Pwede yun para po maintindihan kung paano yung flow ng mga liquid drugs at paano siya ma-absorb, wait lang, ng body. Pwede, tama. Right? That's ano. Okay, that's a very good input. Okay, so that's correct. Okay. Now, class, in terms of dosage force, tama yung class. Importante talaga yung flow property ng isang gamot, okay, as to how it will be absorbed in the body. You know naman, class, di ba, that the less viscous a fluid is, the higher ang chances niya ma-absorb into the circulatory system. Especially, class, if it's administered orally. Okay, mas mabilis siyang bababa kasi sa small intestines. Right? In terms of stability naman, of course, class, kapag ang inyong mixture, ang inyong fluid is more viscous, okay, tendency, class, hindi siya agad-agad nasira. Okay, let's say, for example, you make a syrup out of it. Okay, if you still remember, class, a syrup would usually require 85% sucrose for it to be antibacterial in nature. And at that concentration, class, very viscous na yung ating fluid. Right? Now, in terms of dosage form naman kasi, class, which is okay, drug delivery system, which is all about what we're discussing in physical pharmacy. Okay, importante class sa pag-aralan natin ng rheology because for one class, kailangan ang gamot ay lumabas sa kanyang container. Correct? Okay, paano magagamit ang isang gamot kung hindi siya lalabas sa container niya? Okay? Now, class, kung ang halimbawa, ang inyong solution is very thick, very viscous, pag pour mong ganon, ng bote niya, hindi siya lumalabas, okay? It defeats the purpose, class, of having that drug. Okay, or compounding that drug and placing it in that kind of bottle. Kaya nga, class, wala kang makikitang ointment na nakalagay sa isang bottle. Kadalasan, class, ang ointment nakalagay sa isang collapsible tube o isang yung wide mouth bottle. Okay, walang narrow mouth bottle na ginagagamitan sa isang ointment. Okay, so I hope that makes sense, class. Right? So it's important po because it will directly affect the way a drug is formulated and developed. Definitely. Okay? Kasi nga, class, again, the design of your dosage form will depend also on the flow property of your medication. Kung siya ay free-flowing, class, halimbawa, pag pour mo, lumalabas agad sa container, then that's good. Okay? Kahit anong container ang ilagay mo dyan, pwede. Pwede mo siyang ilagay sa isang narrow bottle. Narrow mouth bottle. Pag sinabi natin narrow mouth bottle, class, yung ganito. Ito yung bote. Yung wide mouth bottle, class, usually yung lalagyan ng mga creams, ointments. Yan. Yung mga semi-solids natin. So it looks something like that. Collapsible tube, alam niyo naman na siguro to. Lalagyan ng toothpaste. Yung ganun. Kaganda ng drawing ko. Nilalagyan ng toothpaste, class. Yan. Alright? So kung collapsible tube ang gagamitin mo, then you can put here very viscous formulations. Like, yun nga, ointment, pastes, like toothpaste, pwede mo ilagay niya kasi you can collapse the tube. Ikot-ikutin mo lang yan, pinutin mo lang, lumalabas na yung product. Okay? So, rheology class is the science, basically is the science and or physics that concerns with the flow of liquids. Okay? How liquids flow and the deformation of solids. So, it's a study of the flow properties of liquids, and it's very important for pharmacists working in the manufacturing field, okay, of several dosage forms. Now, these systems, class, can change their flow behavior when exposed to different stress conditions. Now, class, various fluids kasi have different properties. Okay, pero basically, class, we can divide this into two kinds. We have the Newtonian flow and then the non-Newtonian flow. Okay, pag Newtonian flow, class, ang sinusunod ng isang liquid, yun yung example would be, of course, water, alcohol, wherein, class, as in fluid lang talaga siya. Okay, yung viscosity niya, hindi nagbabago, even if you add stress or you add force to it. Okay, which we will discuss later on. right? Now, class, unlike that of non-Newtonian flowing liquids or fluids, okay, those that follows non-Newtonian flow, right? Ang nangyayari, class, would be, when applied with a shear stress, either siya ay kumakapal, may increase ang viscosity, or nababawasan yung viscosity niya. Okay, we'll talk more about that as we go on. Now, why is it important, class, to study rheology? Okay, well, for two main reasons. Okay, for the manufacture of dosage forms, especially for pharmacists, so the manufacturing of dosage forms and handling of drugs for administration. Okay, so in terms of manufacturing, class, alam naman natin na kapag nag-manufacture ka ng isang gamot, gagamit ka ng mga machines. Okay, machines, class, okay, wherein dapat ang flow ng inyong gamot continuous lang. Okay? So kung alam mo, class, na ang property ng gamot mo is hindi continuous yung flow niya, right? Or halimbawa masyado siyang viscous, then of course you have to consider that when manufacturing those kinds of medication. So these materials undergo process such as mixing, flowing through pipes, filling into containers. Now, flow-related changes influence the selection of the mixing equipments. So again, class, the property of the liquid will dictate, or the fluid that you're making, will dictate what type of equipment you will be using. Kailangan ba malapad yung butas nung pipes, o pwede na yung maliit lang? Eh kung malapad, hindi ibig sabihin, medyo baka pwedeng viscous kasi yung fluid na yun na ginagawa ninyo. And so on and so forth. So handling of drugs for administration, such as the pouring of the liquid from containers, extrusion of ointment from the tubes, collapsible tubes, all depend on the changes in flow behavior of dosage forms. Okay, at the same time, class, halimbawa, kung kailangan mo muna siyang i-shake para numipis, para magkaroon ng flow, or para mag-flow ng maayos yung ating drug, then added yun sa ating label. Now, viscosity, class. Okay? When we talk about viscosity, class, it talks about the internal friction or resistance of fluids to flow. Okay? When you pour water, class, di ba? Normally, parang halos wala ng resistance yon. Okay? Halos wala ng resistance. Alright? So that's why we call it as a non-Newtonian fluid. Almost no resistance. Pero, class, if you say, for example, pour oil. Okay? Magbubuhos ka ng oil. Di ba, class, nagre-resist siya sa flow? Okay? Hindi agad-agad siya nagpo-pour out. What if I make the fluid more viscous? Pag sinabi natin viscous, class, mas malapot. Okay? Pag mas malapot ang inyong fluid, di ba, mas mataas ang kanyang resistance sa pag-flow. Hence, sabi natin, tumataas ang kanyang viscosity. So, it's opposite of fluidity or mobility. Again, class, viscosity is simply talking about the internal friction of the fluid to the flow. Okay? Na, class, ang unit na ginagamit natin is usually in pois. Okay? Ang pois na yan, class, is dependent on the dynes per centimeter squared over the inverse second. Okay? So, ang unit, class, ng pois in CGS is dynes second per centimeter squared. Now, ano ba yung dynes per second yan at yung inverse of your time? Yung dynes per centimeter squared, class, we talked there about shearing stress. While the inverse time talks about the rate of shear. Anong ibig sabihin ng dalawang terms na to? Class, you have to understand these two terms, okay, para maintindihan nyo how it affects viscosity. Okay? Ang symbol na to nga pala ito yung parang letter N. This one's a Greek symbol. Okay, this one is viscosity. So yung F na to talks about shearing stress. Shear stress. Ang G naman talks about the rate of shear. Okay? Ano ibig sabihin pag sinabi natin shear stress? It talks about, class, the force applied to your product. Okay? So it's the force applied per unit area to apply and produce shear. So what do we mean by this? Okay? If this is my dosage form, okay? Kuha tayo ng sample. Hindi ko pa pala nabubuksan to. Di ba? Nabuksan natin. Okay. Just for the sake of say, for example, kasi this is your dosage form. Okay, this is actually salinase para sa ilong to. Okay, shear stress. Okay, how forceful are you agitating this? So, halimbawa, ganyan. Okay, hindi yan forceful, right? So, ang shear stress ko dito, mahina. Eh, pag ginanito ko, right? Nagets ba, class? Okay, I'm putting a lot of stress here, a lot of force. Okay, so I'm applying force to the product inside. Okay, so if I do this, that's minor shearing stress. If I do this, that's a lot of shearing stress. Now, what about pag pinag-usapan, paano man pag pinag-usapan natin ang rate of shear? Okay, means, class, how the velocity at which you change, the rate of velocity change with respect to distance. So, how much are you, okay, kung baga, gaano kalakas mo ina-agitate or gaano kabilis mo ina-agitate yung product natin. So, halimbawa ito, low shear rate to. Okay? Compare that to this. Okay? This is high shear rate. Nagets ba, class? So, are we clear?
Yes po.
Okay, so maliwanag yan, ha? Pag shearing stress, it's the force. Pag shearing rate, gaano kabilis mo in-agitate yung product natin. Okay, both of which kasi, class, are, ito, for most liquids, class, they are both directly proportional. Meaning, the higher the shearing stress I put, usually bumibilis din yung shearing rate ko. Okay, so pag ganito, halimbawa, naalog mo ganun yung product. Okay, so mataas yung shearing stress, mataas yung force, mabilis din yung rate ng pag-agitate sa product natin. Right? So I hope that's clear, class. Now, both factors, class, are important when it comes to viscosity. Okay? Okay. So the viscosity, class, ayan. So simply talks about the force applied per unit area and the rate of velocity change with respect to the distance. Now, when we talk about kinematic viscosity naman, class, it's simply the ratio between your absolute viscosity, which is this one, okay, yung viscosity ninyo, divided by its density, the density of the fluid. So as you all know, class, the density of a fluid can greatly affect its flow property. Okay, and most of the time, class, its kinematic viscosity is directly proportional to your absolute viscosity, but inversely proportional to your density. Okay, so ibig sabihin, class, the less dense a product is, tendency tumataas yung kinematic viscosity niya. And its units, class, is usually expressed in Stokes or centistokes. Excuse me. All right, that's kinematic viscosity. So as you all know, class, Stokes is a unit for, try lang nga natin, kung naalala niyo pa. Para saan nga ba ang Stokes? Okay. Anyone? Stokes, class, ginagamit natin as a unit for? All right. Sige, nakalimutan na ata. So Stokes, class, is a unit for sedimentation. Okay, so pag sa ating kinematic viscosity, yun, it talks about how fast is your, how fast will the solute settle, okay, with the basis or with respect to your viscosity and density. Okay, pag sabi naman natin relative viscosity, it's the viscosity of your substance divided by the viscosity of water. Okay, and oftentimes, class, this one's no unit, doesn't have unit, because nagka-cancel out yung units ng inyong absolute viscosity at saka yung viscosity ng water na gamit ninyo. Right? And we call that relative viscosity. Now, what are some of the factors, class, that affects viscosity? Now, oftentimes, class, when we talk about viscosity, dalawa lang naman ang state of matter na affected dito. Alam nga naman, affected dito ang solid, right? Okay, so we have, class, gases and liquids. Okay, yung semi-solids natin, class, pwede natin siya i-classify na sa liquids natin. Alright? So in terms of gases naman, class, okay, temperature is directly proportional to viscosity. Meaning, as I increase temperature, habang pinapainit ko ang gas, class, mas tumataas ang kanyang viscosity. Why? Mas tumataas kasi ang kinetic energy ng ating gases or gas molecules. So hence, mas nagiging viscous yung gas natin. Okay? Baka isipin nyo, sir, di ba dapat mas mababang temperature kasi mas nagiging liquid siya? Not necessarily, kasi kahit liquid yan, may flow. Pag liquid na ang gas, class, ito na yung susundin niyang properties. Okay? Pero as gas in a gaseous state, as you increase temperature, meaning pinapainit mo yung gas, mas lumalakas yung kanyang viscosity because of the increase in kinetic energy. Okay? So, sir, does that mean pag mas mainit, mas mahirap huminga? Pwede, I guess. Okay? Pero class, most of the time, yung paghinga na yun kasi is brought about by the dilation of your bronchioles. Okay? Most often, class, pag mainit, depende kasi ito, usually pag asthmatic din, pag asthmatic naman, nagko-constrict yung kanilang bronchioles. Okay? Pero kasi pag nag-dilate din kasi ang bronchioles mo, tipong ang bilis pumasok ng hangin, mabilis din lalabas. Kaya parang hindi ka nakakahinga ng maayos. Yung parang naghahabol ka ng hinga pag mainit. Okay, ba? Inhale mo nga, marami. Pag exhale mo, marami rin lumalabas. So parang hirap kang huminga. Kasi nagdadilate yung bronchioles mo. Okay? So, pag nag-constrict naman kasi yung bronchioles, normally nangyayari ito pag malamig. Okay, yun yung parang hirap ka huminga kasi hindi pumapasok yung hangin na pinipilit mong ihinga. Okay? So, does that make sense? Right? So, did I answer your question, Mr. Reyes?
Yes
Right?
po, sir.
Alright, so thank you. Okay, good. So pwede rin naman yun. Excuse me. Ayan. So anyway, liquids naman class, if you increase temperature, nababawasan yung viscosity, which is true, right? Okay, mas nagiging less viscous ang liquids natin kapag pinapainitan natin. Okay? And then class, a lesser molecular weight would indicate lesser viscosity, okay, for your liquids. Now, addition of electrolytes class, say for example, nag-add ka ng electrolytes sa inyong liquid, ang tendency class, it tends to reduce the viscosity. Okay? So, mas, especially class kung ang inyong, say for example, solute particles, okay, magkakaroon ng mas more affinity towards the electrolytes, especially if they are of opposite charges. Okay? And then if you add organic substances naman to your liquids, ang tendency is tumataas naman yung viscosity. Right? So this is something class that I need you guys to remember as importante kasi ito class na maalala natin when it comes to the viscosity of our substances. Ano yung mga factors that affects viscosity? Okay, now, what is about Newton's law? Okay, alam natin, di ba, Newton made a law on motion. Okay, so ang isa sa mga ginawa ng class na law ni Newton is about the viscosity of liquids. So according to Newton's law class, the higher the viscosity of a liquid, the greater is the force per unit area required to produce a certain rate of shear. Okay, so meaning class, okay, ang force na kailangan ko para mag-flow siya. Okay, so halimbawa class, kung ito yung aking bote, halimbawa, according to Newton, the higher the viscosity, okay, kung mataas ang viscosity nito, para mag-flow out yung fluid natin, kailangan niya ng maraming force. Okay, it needs a lot of force. You need to apply a lot of force para lumabas yung fluid na to. So, ibig sabihin, high shearing stress. Okay? High shearing stress is required para mag-flow yung liquid na yan or yung kanyang rate of shear. Okay? So, how fast does it flow out of the bote? Okay? So, again, class, pag mataas ang viscosity daw, ulitin ko lahat, pag mataas ang viscosity ng isang liquid, kailangan niya ng force, mataas na force, which is the shearing stress, para mag-flow out. Okay? Now, gaano kabilis yung pag-flow niya would be dependent on the rate of shear. Okay? Rate of shear, meaning yung flow niya sa ating, yung flow ng liquid natin. Right? Excuse me. Okay? So are we good, class? Or yung, pag sinabi natin yung rate of shear, right? Yung agitation na ibibigay natin para mag-flow out yung ating fluid. Okay? So what are some of the instruments, class, used to measure viscosity? So we have, class, what we call the viscometer. Viscometers, class, comes in two forms. Merong single or one-point viscometer, and then we have the multi-point viscometer. Pag one-point viscometer lang yan, it expresses the viscosity at a single rate of shear at one point lang on the curve. Okay, while multi-point, class, provides several rates of shear, wherein it provides many points on the curve. Now, equipments, class, na ginagamit natin for single point, we have Oswald viscometer and falling sphere. Ito yung pinaka-common, class, yung Oswald. Okay? And for the multi-point naman, we have the cup and bob or the cone and plate. Okay? Ang Oswald viscometer, class, most of the time applicable for Newtonian fluids. Okay, Newtonian kasi nga 1 point lang na isang 1 point na yung kanyang ang mini-measure natin dito, or only a single rate, okay, of shear. While for the multi-point, class, can be used for both Newtonian and non-Newtonian fluids. Now, paano ba nagkaiba ang isa sa isa? Okay, so for 1-point instruments, class, it provides a single point on the rheogram. Rheogram, class, talks about viscosity and shear stress. Okay? A rheogram, class, ano yung shear stress? Ano ito yung viscosity sa y-axis? Okay? Normally, class, di ba, kapag nag-add ka ng shear stress, nag-add ka ng force. Okay? Ano nangyayari sa viscosity natin? Di ba, usually, ang viscosity natin, bumababa. Okay? Mababa yung viscosity niya. So, pwedeng pag ganito, okay, pwedeng, may ibang fluids kasi, habang nag-add ka ng shear stress, tumataas lalo ang viscosity, or pwedeng, walang effect sa viscosity. Pag walang effect yan sa viscosity, class, yun yung Newtonian flow. Right? Ibig sabihin, habang inaalog ko siya, kahit alugin ko siya ng gaano kalakas, the viscosity of it will never change. Okay? The viscosity doesn't change. So, since the rate of shear is directly proportional to shearing stress. Now, the capillary and falling sphere are used only for Newtonian, once again, Newtonian materials. So this is what we, ito yung tsura kasang Oswald viscometer. It's used to determine the viscosity of a Newtonian liquid. Both dynamic and kinematic viscosities can be obtained because you can use this for the fluid and then the water. So makuha mo yung relative. And then yung for kinematic viscosity, kaya natin makuha dito. So kailangan mo lang is the density. Now, when a liquid flows by gravity, the time required the time required for the liquid to pass between two marks through a vertical capillary tube is determined. So kung mga class, meron kang starting mark here. Okay, and dito tapos yung stop mark. So, oorasan mo yan, class, how fast does this liquid go down? Okay, now class, time is very important here to determine viscosity. So, the lower the time it takes for the fluid to go down, from start to end, start to stop mark, anong masasabi natin sa viscosity ng ating fluid? Is it?
More viscous po.
Very good. So, mataas, class, yung kanyang viscosity. Okay, so therefore, class, kung mabilis lang siyang bumaba, kasi sabi natin, mababa yung viscosity. Right? Now, please take note, class, during the entire process, you need to control the temperature. So, kailangan constant yung temperature natin because, again, temperature, class, can greatly affect the viscosity of fluids. Okay? So, we have to maintain temperature here. Now, for falling sphere naman, class, similar ang principle. Similar ang principle, yun nga lang, okay, meron tayong, ang tinitingnan natin sorry. Okay, ang tinitingnan natin dito ay yung pagbagsak ng sphere sa loob ng isang tube. Okay, so the sample and ball are placed in the inner glass tube and allowed to reach temperature equilibrium with the water in the surrounding constant temperature jacket. So, kung ba, class, again, similar to what we do with Oswald, okay, kailangan, class, maintain yung temperature ng buong system dito. Maintain yung buong temperature niyan. So, the tube and jacket are then inverted. So, babalik ta rin mo siya. Make sure na ang ball natin nandun sa ilalim. Okay? Tapos, class, pag ready ng lahat, equilibrium na ang temperature, babalik ta rin mo siya. So, from this figure, babalik ta rin mo siya. Ngayon, ang susukati mo dyan, class, is yung oras na bumagsak ang ball na yon from top to bottom. Are we clear? So the time for the ball to fall between the two marks is accurately measured and repeated several times. Again, class, similar to Oswald. Okay, time is the parameter that we're measuring here. So again, the less time it takes, okay, to kung mabagal yung time natin, mababa yung time. Ay, parang baliktad. Sorry. Parang baliktad yung pagkakasulat ko dito. Okay? Pag mababa ang time, class, pag mabagal kasi sinabi ko kanina, no? Pag mababa ang time, ibig sabihin mabilis siyang bumagsak from one point to the next point. So dapat, class, mababa rin yung viscosity. Sorry about this. Okay? Less time it takes to go down from this point to this point. Less time. Okay, let me just write it down. Less time, ibig sabihin, less viscous yung fluid natin. Sorry about this, Okay? At class, kung mataas ang time, okay, indicating that it's more viscous. So are we clear? More time it takes for the fluid, okay, to go down to the stop mark. Okay? Am I clear? Sorry sorry, mali yung pagkakasabi ko kanina. Okay? Ang pagkaka-label ko. Kaya napaka-importante talaga ng label. Right? Tandaan yan, sa lahat ng bagay, importante ang label. Alright? Especially pag nagko-compute, okay, nagagawa tayo ng given. Especially pag nag-experiment kayo. So, very important, class, ang label. Okay, hindi lang naman application yan sa science. Okay, kaya sabi nila, pag gusto mo magmahal ng isang tao, magmahal ka ng isang pharmacist. Siguradong may label kayo. Okay, kasi importante, alam nila kung gaano ka-importante ang label sa buhay. Alright? So, anyway, class, similar to this again. Okay, less time it takes for the ball to fall down. Okay, indicating less viscous. And if it's more time for the ball to reach its stop point, okay, then it means that the fluid is more viscous. Okay. Now, what about for multi-point? Okay, multi-point instruments. So used with non-Newtonian systems, pwede rin naman sa mga Newtonian systems to. So the instrumentation used must be able to operate at a variety of rates of shear. Okay, so usually we can use cup and bob or cone and plate viscometer, okay, with both types of flow system. So ano ba yung cup and bob na yan? It is a multi-point viscometer that belongs to the category of rotational viscometer. Kung we say rotational viscometer class, kanina di ba, 1 point lang yon, up, down. Okay, yung movement ng ating, yung pag-measure ng viscosity natin. Ito class, rotational, kaya siya multi-point. Okay, paikot yung pag-measure ng viscosity. Now class, usually isa sa mga viscometer din na ginagamit natin is yung parang paddle siya. Parang siyang paddle. Ano yung paddle? Okay, parang yung sa paddle. Ginagamit sa hazing. Hindi, paddle, basta paddle. Okay? Tapos kasi diba, kapag mabilis yung pag-flow ng paddle na pag ganun, paikot, ibig sabihin, less viscous yun. Pero kung yung paddle na yan, hirap umikot, okay, hirap siyang umikot na ganun, ibig sabihin, very viscous yung fluid mo. Right? So anyway, so the sample class is placed in a cup and the bob is placed in the cup on an appropriate height. Okay, so ito yung bob niya. Now class, the sample is accommodated between the gap of the cup and bob. Now the cup and bob class is made to rotate and the torque, okay, torque class meaning yung pag-ikot, kasi ikot yan, di ba? So ang force class that is required to cause rotation would be the torque. Okay? So I hope you're familiar kayo sa term na torque. Okay, ito yung torque. Ito, torque ito. Okay? That is equivalent class to the force being applied to your fluid to facilitate flow. So hence class, that's considered as our shearing stress. Okay, so the torque class, so the cup and bob is made to rotate and the torque from the viscous drag is measured by a spring or a sensor in the drive of the bob. So dito class, meron dyan nagme-measure ng torque. Okay, or the shearing stress. So hence class, it measures how much force is needed para mag-flow yung liquid natin. Okay? So hence class, I can determine, or ang isa sa mga nakukuha ko dito na value, it's not simply the time lang for one, di ba, for the flow, for the fluid to flow. So hindi ko na nakukuha dyan yung shearing rate. Kinakuha ko dito class sa cup and bob is the shearing stress as well. Okay? So the force required for the fluid to flow. Alright? So, yun. Okay, so kumbaga sa pagbabike class, di ba, gano'ng kalakas yung papadyak mo para gumalaw yung gulong. So, yun yung torque. Alright? Of course, kasi that torque is very dangerous din, lalo sa tuhod. Kaya dapat magaan na lang umpisa lagi ng pedal. Anyway, next one is the cone and plate viscometer. Okay, similar class ang principle niya with this one, the cup and bob. Okay, ang difference ng class is the sample is placed at the center of a plate, which is then raised into a position under the cone. Okay, the cone is driven by a variable speed motor, and the sample is sheared in a narrow gap between the stationary plate, which is this one. Okay, ito yung plate natin, right? And a rotating cone, which is this one. This one is the rotating cone. Okay. Okay, the rate of shear in revolutions per minute is increased and decreased by a selector dial, and the torque, the shearing stress, produced on the cone is read on the indicator scale. So a plot of RPM, rates per revolutions per minute, okay, or rate of shear versus scale reading, shearing stress, may be plotted. Okay? Now, class, ulitin ko lang para mas klaro tayo. Yung torque, the force required to cause the fluid to flow, is what we call the shearing stress. Okay? Shearing stress is the force required to make a fluid flow, to make a liquid flow. So hence class, the higher the shearing stress required to make a liquid flow, the higher will be the viscosity, most likely, right? Okay, and then of course, class, in relation to shearing stress, okay, how fast, okay, is the fluid flowing? Okay, based on the shearing stress. So ang shearing rate refers to how fast is the liquid flowing with respect to time. How fast? E gaano kabilis siya nagfo-flow with respect, again, to the stress that you're applying. Okay, to the force that you're applying. So most often than not, class, pag tinataasan mo ang stress, you increase the force, ano nangyayari sa, sa flow or sa shearing rate? Okay, obviously, class, tataas din dapat yung rate of flow. Kasi as I increase the force, di ba nga, ganun, mas bumibilis yung flow property or yung pag-flow ng ating fluids or liquids. Okay? Alright, so what are the different flow systems that we have? So there are two lang naman, class, Newtonian and non-Newtonian flow. Pag Newtonian yan, class, then according to Newton's, okay, Newton was the first one to study the flow properties of liquids in quantitative terms. Now, liquids that follows Newton's law of flow are called Newtonian fluid. Now, Newtonian fluid, class, is a fluid whose stress versus rate of shear curve is linear and passes through the origin. Origin, class, meaning here. The origin point. Now, the constant of proportionality is known as viscosity. Excuse me. So meaning, class, as I increase the stress, I increase the force, tumataas din yung flow ng ating fluid. Correct? Diba, pag inalog ko nga ito, ganun. Pag inalog ko ganyan yung tubig, class, mabilis din yung pag-flow niya. Alright? So the higher the stress, the higher be the shear rate or yung pag-flow ng ating fluid or ating liquid. Okay? Now, class, with respect to viscosity naman, sabi natin, class, if it's a Newtonian fluid, viscosity, class, never changes. Okay? Constant ang viscosity ng Newtonian fluids. Okay? Or those that follows Newtonian flow. Kahit taasan ko ang shearing rate ko, taasan ko yung shearing stress, hindi magbabago ang viscosity niyan. Maliwanag ba tayo? That is a Newtonian fluid. Kaya nga, example of dito, class, would be water or alcohol. Diba, class? Kahit alugin ko ang alcohol, hindi naman nagbabago ang viscosity nito. It's still fluid. Okay? Right. Pero, class, syempre, pag nilakasan ko yung pag-alog, yung force applied to it, then, class, mabilis din yung pag-flow ng fluid natin. That's why, class, constant ang viscosity and the shear stress is directly proportional to your shear rate. Okay? Now, ang dali lang ng Newtonian, right? It's a very common type of fluid. And what about non-Newtonian fluids, or those that have non-Newtonian flow? So non-Newtonian bodies are those substances which fail to follow Newton's law. So there are two types of non-Newtonian fluids, class, or non-Newtonian flow. We have shear-dependent and time-dependent viscosity. Okay, meaning, for the shear-dependent viscosity, class, ang kanyang viscosity is dependent on the shear stress and shear rate you're applying to the fluid. Okay, so we have three types. Plastic, pseudoplastic, dilatant. Okay, dilatant flow. For time-dependent, class, viscosity, ito naman, class, yung type of viscosity na nagbabago yung viscosity niya based on the time you're giving it to rest. Okay, you're allowing it to rest. The time you are giving the fluid to rest. Alright? Okay, ang hirap sabihin yan. Ipakita lang natin. Explain natin isa-isa to. Okay, ano ba ibig sabihin pag shear-dependent and time-dependent? Again, class, we're referring to your stress here, the shear stress and or shear rate. Okay? Now, let's talk about the shear-dependent viscosity. So for plastic flow, ano ba yung plastic flow? So it's usually associated, class, with flocculated particles. Okay? It only starts, flow of the substance only starts when the yield value is exceeded. Ano ba yung yield value na yan, class? Ito yung yield value na yan. Meaning, class, you have to reach a certain amount of force. You have to use a certain amount of force before the fluid starts to flow. Okay? Nagets ba, class? Meaning, upon standing, pag inalog ko siyang ganito, isang ganyan lang, okay, obviously, mahina yung force na ina-apply ko dito. Ganyan. So, hindi siya, class, mag-flow. Ano, pag ganyan ko lang, okay, it won't flow. Right? You have to reach a certain amount of stress, a certain amount of force before it starts flowing. Yun yung plastic flow. Okay, maliwanag ba tayo dito, class? Are we clear? Kaya tingnan nyo, class, di ba? Pag yan ay Newtonian fluid, di ba, it starts at the origin point. Tapos, shear rate and shear stress is Newtonian. Okay? Is directly proportional. So, linear yung kanyang graph. Ang plastic flow, class, linear din naman. Okay? Linear din yung kanyang flow. Yun nga lang, you have to first apply a certain degree of force. At yung force na yun, class, is considered to be your yield value. Okay, whatever that force is, it could be 10 newtons, 40 newtons, bahala na, depende kung anong liquid yun. Okay, so yung yield value na yun is very important. You have to reach that yield value first before the liquid starts to flow. Are we clear? Are we good? Ang Newtonian fluid kasi, class, you don't need to add stress para lang mag-flow siya. I-boost ko lang ganyan, nag-flow na yung liquid. At syempre, pag inalog ko yan, mas bumibilis yung flow niya. Maliwanag? Pag pseudoplastic yan, class, pag ginanito ko, walang lalabas. I have to apply a certain amount of force before it starts flowing. Okay? And that's considered to be plastic flow. Right? So the plastic flow, class, curve does not pass through the origin. Okay, so hindi siya dumadaan dito. And it intersects the shearing stress axis at a particular point referred to as your yield value. Okay, so ito yung yield value natin. Whatever that value is, that's the yield value. Okay, you have to exceed that value or that force. Okay, so yield stress or yield value, okay, should be exceeded before a substance starts to flow like a liquid. Are we good? Are we clear? Right, that's plastic flow. Okay, so yun na yan. Normally, class, viscosity is high. Okay, at if you're not applying stress, pero as you apply stress, class, you need to reach a certain point before it starts to become liquid. Kaya, class, yung graph niya para gumaganyan. Okay, before it starts to flow, you need to apply certain amounts of stress, shear rate. Okay, so kung na-notice yung class, okay, mag-umpisa lang gumalaw ang ating, okay, nag-umpisa lang, class, gumalaw ang ating fluid after a certain amount of force is applied. Are we clear? Are we good? Basta kasang shear rate, pinag-uusapan na dyan is yung pag-flow ng fluid natin. Okay, how fast or how slow is it flowing? Okay, shear stress is the force I'm applying. So are we clear? Okay, yeah. Right, so examples of this class would be semisolids like ointments, paste, creams, cerates, cataplasms, butter, and margarine. Okay. So, yeah. So, ang proportionality dito, class, is if I'm using higher, okay, force, shear stress, or shear stress or shear rate, ibig sabihin, okay, if I need more shearing force or shearing stress, sorry, shearing stress and shearing rate, pati ako nalilito, okay, to reduce its viscosity, okay? So, kumbaga, the more I need to apply more force to reduce the viscosity of certain fluids or of fluids that follows plastic flow. Okay, what about pseudoplastic naman? For pseudoplastic, class, ang behavior niya is almost similar to that of a plastic flow. Kaya siya tinawag na pseudoplastic. Ang difference lang, class, is dumadaan siya sa origin point. Okay? Ibig sabihin, applying pressure, class, for pseudoplastic flow, nagkakaroon ng flow property yung liquid. Unlike that of plastic flow, you have to reach a certain value before it starts flowing like a liquid. Okay? So for pseudoplastic flow, class, this is a type of flow behavior. It's also called as shear thinning. So materials are more fluid when it's stirred faster, or meaning when you apply shearing stress. Okay, so the curve for pseudoplastic material, class, begins at the origin. Unlike that of plastic flow, it doesn't begin at the origin point. Okay, ito yung origin point natin. Origin point. Okay, so the curve rheogram for pseudoplastic material is due to a shearing action on the long chain molecules of materials such as linear polymers. So ano ibig sabihin lang nito, class? Okay, the more I'm putting the more I'm putting pressure, mas nagiging liquid yung fluid natin. Mas gumaganda yung flow property niya. Pero pag mabagal or konti lang yung force na ina-apply ko, okay, less yung kanyang flow properties. Are we good? Okay, I hope I'm making sense. Okay, so yun siya. So that's pseudoplastic flow. Again, kasi pinagkaiba niya lang sa plastic flow is, plastic flow, kailangan mo munang ma-meet yung kanyang yield value. You have to exceed the yield value. For pseudoplastic flow, class, it doesn't have a yield value. Applying stress to it will, again, still make it flow. It's still going to make it flow. Yun nga lang, the more force I'm applying, the more ang kanyang liquid property, the more yung kanyang magiging flow property. Okay? So, mas tumataas yung shear rate niya. Okay. So, ayun. So, simply class, the shear rate increases as more stress is applied. Okay? Pero class, hindi siya linear. Okay? The graph won't be linear. It's more of a curve. Okay? It's more of a curve. You have to reach a certain stress point para mag-shoot up yung flowability ng isang liquid. Para mas maging flowy, tama. Okay? Mas maging liquid yung property ng ating, mas gumanda yung flow property ng ating liquid. Yan. Okay? What about dilatant? Dilatant flow naman class is known as shear thickening naman. Kung ang pseudoplastic class is shear thinning, ibig sabihin, the more na inaalog ko, mas nagiging liquid, mas nagiging less viscous siya. Yun na lang. For dilatant flow class, the more na inaalog ko siya, mas lalo siyang kumakapal, mas lalo siya nagiging viscous. Are we clear? Very good. It's the opposite of pseudoplastic. So class, when stress is removed, a dilatant system returns to its original state of fluidity. Okay? Are we clear? Okay. So yun siya. So class, ibig sabihin, the more I'm applying force, okay, the shear stress, the shearing rate decreases. Unlike kanina, di ba? Sabi natin, increase ang force, tumataas yung rate. Correct? Especially for Newtonian fluids. Okay? For pseudoplastic class, same lang naman. The more force I apply, okay, mas tumataas din yung shearing rate niya or yung flow property niya. So hence class, nagdi-decrease ang viscosity. Okay? Pero for dilatant flow class, the more force I'm applying, okay, mas nagiging less ang kanyang flow property. Mas bumababa ang kanyang shearing rate. Ibig sabihin yung pagbagsak niya from the container. Mas bumababa. At the same time class, in this case, tumataas yung viscosity. The more force I apply to it. So kung the more force I apply to it, mas nangangapal siya. Okay? Yan yung dilatant. Isipin nyo lang class, para siyang nagda-dilate. Okay? Mas kumakapal. So are we clear? Okay, so these are some of the common behavior class of our pseudoplastic versus dilatant. So in comparison to Newtonian flow. So sabi natin, di ba, increase in shear stress, bumibilis yung flow. For pseudoplastic class, initially, hindi naman siya ganun, hindi agad-agad siya nagfo-flow. Okay, so you have to increase the force, okay, bago siya mag-flow. Right? So yung shear thinning. Shear thickening naman, opposite of that. So class, for Newtonian fluids, again, viscosity is not affected by the shear rate. Okay? Pero for pseudoplastic class, viscosity decreases, okay, as you apply more force or the shearing rate increases. For dilatant naman, as you increase the shearing rate, mas tumataas naman yung viscosity. Mas kumakapal siya. Maliwanag? Okay, so again, for pseudoplastic class, the more force I apply to it, mas numinipis yung liquid. Mas nagiging less viscous. For dilatant, the more force I apply to it, mas lalo siyang nangangapal. Okay? Now, what about those class for time-dependent non-Newtonian flow or non-Newtonian fluids? So we have two types class, thixotropic and rheotropic. Okay? Thixotropic class, ito yung sinabi ko sa inyo before. An example of which would be ketchup. Okay? So it's a reversible gel-salt transformation. What do I mean by this? Okay, it becomes gel, nagiging solution siya, ibig sabihin nagiging fluid siya, kapag you apply force to it. Pero if you leave it to stand on its own, wag mong gagalawin, pwede siyang bumalik class sa kanyang gel formation. Okay, sa kanyang gel-like structure. Are we clear? Okay, ulitin ko sorry, let me explain further. So the breakdown of the structure, it's shear thinning class, okay, that does not reform immediately when stress is removed or reduced. Thixotropy class, thixotropy is an isothermal and comparatively slow recovery on standing of material of a consistency lost through shearing. Okay, what do I mean by this? If I leave it alone class, it's gel. Okay, gel yung structure niya, like ketchup, right? Kung notice nyo class, konting alog-alog yung ganyan, di ba? Para siyang gel. Para siyang gulaman. Pero pag inalog ko siyang ganito, yan, halimbawa, ginagaya ko yung ketchup. Di ba? Pag gusto natin simutin yung ketchup, ginagaya natin. Okay, I'm applying shearing stress. I'm applying force. Class, notice ano nangyayari sa consistency ng ketchup. From a gel-like structure, nagiging fluid siya. Okay, nagiging liquidy siya. Nababawasan yung kanyang viscosity. Kaya class, for a thixotropic solution class, or thixotropic fluid, upon applying shearing stress, okay, numinipis yung fluid. Okay? Nawawalan siya ng viscosity. Pero class, decrease the shearing stress or let it go back to excuse me. Hayaan mo siya class mag-stand. Bumabalik class sa gel formation yung ating solution. Okay? So are we clear? Kaya ang tawag sa kanya glass is a reversible gel-sol transformation. Gel na nagiging solution na pwedeng bumalik ulit sa pagiging gel if you remove the stress, the shearing stress. Make sense? All right. So class, why is it significant? It's used as I mentioned during the course dispersion topic, most suspensions and emulsions class follow a thixotropic flow. Okay, meaning upon standing, gel ang kanyang structure, pero if you apply force to it, like sa suspension, shake well. Okay, as you're shaking it class, okay, nagiging solution siya ulit. Right? And it imparts longer therapeutic action. What about rheopexy? Okay, rheopexy naman class, on the other hand, is a phenomenon in which a solid forms a gel more readily when gently shaken or otherwise sheared than when allowed to form the gel while material is kept at rest. Ito naman class, opposite ng thixotropic. Kung si pseudoplastic, ang opposite niya is dilatant, ang opposite ng thixotropic is rheopexy or rheopexy. Okay? Ito naman class, habang inaalog mo, as you're applying shearing stress, mas kumakapal yung fluid, mas nagiging gel-like yung kanyang structure. Are we clear? Pero if you keep it at rest, if you remove the shearing stress class, anong nangyayari? Bumabalik siya sa liquid state. Are we good? Are we clear? Okay, so yun siya class. Yun yung rheopexy. Okay? So, ang ano lang naman dito class is, okay, it's apparent viscosity. Normally, for thixotropic solutions, makapal, thick siya, mataas ang viscosity kasi nga parang gel siya, right? Pero if you apply stress, okay, at a certain period of time, as the longer you apply stress class, the longer you apply stress to a thixotropic solution, the viscosity decreases. Make sense? Okay. Pero for a rheopectic solution or a rheopectic fluid, at zero time class, okay, if you leave it as is, it's liquid. The viscosity is low. So liquidy siya. Okay, manipis yung fluid. Pero class, if you apply stress, okay, you apply shearing stress as the longer you apply shearing stress class, mas tumataas naman yung viscosity ng rheopectic fluids.